wait. Before you scroll past thinking this is just another boring tech video with more math than memes, hold up. Ever wondered how your inbox magically knows what's spam? Or how Netflix just gets your taste in shows better than your best friend? That's not luck, fam. That's classification. And today we are diving into this beautifully nerdy world of binary choices, multi-class chaos and multi-label madness, with a dash of humor, a sprinkle of visuals, and yes, sigmoid sauce on top. Ready to turn your confusion into a confusion matrix? Let's go! Now, in the previous videos, as we have learned about machine learning, we have learned in that supervised learning. In supervised learning, we have two terms, that is classification and regression. In a previous video, we learned about regression. We created one model to that, right? And we explored about those things. Now, in this video, we are learning about this classification. It is the term of supervised machine learning, okay? So why this classification? So now classification is used in supervised learning to automatically assign data into predefined categories, okay, enabling efficient decision-making, pattern recognition and prediction in various real-world tasks such as spam detection, disease diagnosis and image recognition. This is theoretical definition. Now let's understand this with an example, okay. So let's get real for a second. The today's world, it's noisy, messy, chaotic, right? We don't need information, we need to make decisions fast and right. Is this email spam or not? Is that tumor benign or malignant? Is that cute animal a cat or just an extremely fluffy pillow? Here what important thing we have to keep in mind, that is classification is the term of supervised machine learning, okay? And here we get the data into categories, okay? Classification into 2-3 different kinds of categories we get, and in that we have to classify the data. Here the simple concept is that, okay. Now what is this classification in actual is? Classification is type of supervised learning. It is going to come in every term, okay. It is a term of supervised learning. Now that you know, goal is to predict categories, okay. We get the answer into categories, okay, or class label. And in supervised learning, as we have labeled data, right, we have to keep this in mind. I have taught supervised learning in very depth in my previous videos, okay. You have to watch those previous videos before you're watching this video. So what this classification is? Simple. It's about sorting things into group based on what they are. Think of it like your grandma organizing her kitchen. Sugar goes here, salt goes there, and that mysterious spice from 2003, yeah, it goes in the trash. So classification equals to organized chaos. Machine learn from examples to put things into the right bucket, okay. So now this term we have understood, like what is classification, but there are how many types of classification? Now let's understand that. So type of classification are binary classification, multi-class classification, multi-label classification and imbalanced classification. First is binary classification. Spam versus not spam, disease versus no disease. Should I text them first or die overthinking? Next we have this multi-class classification. More than two options, because life isn't just black and white, right? Recognizing whether a photo is of cat, dog or a rabbit. Predicting which subject you will nap through in class, like maths, history or physics. Simple terms, okay? Next we have is multi-label classification. Now this is where it gets juicy. One thing can have multiple labels at the same time. For example, a YouTube video like this one can be funny, educational, life-changing. Machines can assign all relevant labels at once, multi-talented like you. In imbalanced classification, it is not mostly used, but still we will learn about it. One class is having samples more than others, okay? And for example, in fraud detection, it is being used. Now let's learn what is logistic regression. Okay, logistic regression, it is a statistical method, like how in the previous videos we learned about linear regression. Here we are having logistic regression. Simple, what, don't look at this definition. Okay, what will happen in the logistic regression? We are going to get answer whenever we are going to build the model. In linear regression, we were getting a linear line. Okay, we were getting linear. There were some of the assumptions that we have to follow when we were giving data. Okay, and here in the logistic regression, what is it? Is a statistical method. Okay, we have to predict the probability that a given input belongs in a particular class or not. Yes or no, true or false. These kinds of answer we want from the model. Okay, we don't want any particular number. When in the previous video when we were learning about linear regression, we created house price prediction, right? House price prediction example we created, and there we were getting the number, the price, when we were giving the diameter, we were getting what price we should keep of that area. Okay, like that we were getting. So here we don't have any price, we don't have any number, we are not getting output into the numerical forms, we are getting output into the categorical forms, that is yes, no, true, false, this, that, and all those things. But we are getting it into 0 or 1, binary. Okay, like that we are getting. So it is mainly used for binary classification, where the output is either 0 or 1. Okay, simple terms, no difficult task. Now when we are learning about this logistic regression, we should know what is the behind the scenes logic, what is working when that logistic regression is being created, or when it follows. Okay, what is the terminology behind that logistic regression? That is sigmoid function. Okay, so we will quickly understand the sigmoid function a bit, like how it is, what it is. Okay, I'm not going to explain it in depth because most of the concepts are cleared in the previous videos also. Okay, so here this sigmoid function is there. Okay, y equals to 1 and divide by x means the predicted probability it is going to show. Okay, next we have a1 and a2, those things are intercept and slope. How to calculate those things, that also I have told in the previous video. Okay, and e's value is what is there, it I have mentioned over here. Okay, 2.71828, that is the e's value. Okay, so we have to simply work with this formula. Simply this is going to follow, means this is going to be followed by that model, and then it is going to give us the outputs. Okay, give us those answers in the binary forms, that is 0 and 1 form. Okay, don't think much about it. We are going to create one model. Okay, and then we'll understand it in the depth, like how we are getting outputs. Okay, but which function it is using? It is using sigmoid function. The behind logic of the logistic regression is with the help of this sigmoid function. And how is this sigmoid function? Okay, you can see over this. Now let's start creating our model. Okay, so open up your Jupyter notebooks, give it a names, load those libraries, and then we'll start. So first things first, what we have done, we have summoned the machine learning gods. Okay, Skylearn, NumPy, and Pandas. These will help us load data, split it, and most importantly train our logistic regression model. Okay, in those we are familiar with NumPy, Pandas, Matplotlib, Seaborn. Okay, from scikit-learn we are taking model selection, what is train, test, split, how it works. I have explained that. Logistic regression you are going to see in this video. Confusion matrix, accuracy score, classification report, these terms I am going to explain a bit by bit. Okay, now as we have loaded the libraries, we need data set to work with. Here also I am going to create a dummy data set. Okay, data set by myself only, or you can also take any of the CSV files or any of the external data set you want. Okay, if you are working with. For right now our main purpose over here is understanding, and for understanding, if we take a bit small data, then it will be clear. Okay, first we can work with this small data, and then we'll try to swim in the ocean. Okay, so let me create the data set and I'll explain it. So here what I have did is I have created the dummy data set. Okay, in that what is there, I am having the count of if I am getting any mail, and in that I am how many links are mentioned in that mail. Okay, suppose you are getting a mail and in that there are two number of links. Number of links means how many number of links are present in that mail. Next to that, how many capitalized words are being used, that is mentioned. Okay, that count we have to take, and if there is, then is spam or not, it will going to detect. Okay, If 2 is there, then yes it is. If 5 is there, then yes it is. If like that, it is being categorized. Okay, so we have given 20% of the data or 30% of the data that you will understand when we will split the data into train, rest, split, right? That time we can understand that how much data we are giving for machine to learn. Next is that I have stored it in the df. Okay, for to data I have converted it into df, data frame. I am printing it into data frame. Okay, you can see this. Let's do one trick. You can see if I change it into series, in pandas as we know we are having data frame and series. Okay, so here you can see how this data is being printed over here. We don't want that. Okay, number of links, okay, this much, but we are not getting a clear understanding with this data. That is why data frame is used. Okay, and then df.head, we know what it is doing. It is showing some of the part of a head, right? No, it is going to show the first 5 rows or first 5 rows of our data. Okay, if you want to mention any number, that how many numbers of rows you want to see, then you can mention it over here. Simple data is not, no complex things are over here. Okay, until now it is very clear that how we are working. Okay, next we are simply going to visualize it now. So now let's visualize this. Okay, I have created this visualization. You know, from Seaborn I have took scatter plot. Then for x I have assigned number of links, and y I have assigned number of capitalized words. Hue, third variable I have took is spam. Okay, you can see blue dots are there, then it is 0, means there is not spam, and if 1 is there, then it is spam. So you can see how our data is scattered. Okay, we have spam mails also, and we have not spam mail also. Okay, data df that we have did, then title and show, we are familiar with it. This is a scatter plot, we have created it. Okay, number of links, number of capitalized words, it's spam. This is hue, we have created. Okay, you can already spot patterns. The spam messages have more links and more capitalized letters. Okay, spammers really love caps lock and hyperlinks. Now as machine needs some of the data to work with, and then it can understand, and then it can follow that pattern, right? So we have to split some of the data. Whatever data we are giving, we have to split that data, and we have to tell that learn these patterns, learn whatever insights are there in this data, and then work with it. So we have to assign x and y. So let's split our data. So now we have splitted our data. Okay, you can see this x is over here, y is over here. For what values I have assigned to x means like independent variables, these are. Okay, the values which I have assigned to the x, those are independent variables. Here also there is independent and dependent variables. Okay, don't forget those things. So here what is there? Number of links and number of capitalized words. You have to understand this, means I am telling machine that you have to understand these things. Okay, and then in y what I have stored is spam or not, means like this is the dependent. Okay, if there is in the number of links, in the mail there is number of links or capitalized words, then it is going to be categorized, right? First, so a spam variable has to see those first number of links and that variables, right? That columns, right? So these things are there. We have targeted, we have categorized independent and dependent variables. Okay, next what we have did is trained, test, split, taste test. You remember? So xtrain, xtest means some of the data to training and then test within that data, then some of the data for the training and test on that data. Okay, so we have to do this thing. Then train, test, split, how we are writing, what we are want to split for testing and training data, we want to split x and y variables. So we have given those. Then how much size, like how to categorize that, what is the test size, and what is, means how much data we should take for testing and how much data we should keep for training. How we are going to do? We are going to give that to the machine with this test size. Test size we have mentioned 0.3, means 30% of the data is going for testing. Okay, sorry, training. 30% of the data is going for training. Okay, and what this random state is there, 42 we have mentioned, but it is not like it should be there. Okay, means now as we have data. Okay, it starts from 0, 1, 2, like that it is starting. Okay, consider this thing. Okay, and whenever we are splitting the data into some 30% and then rest of the 70%, we are splitting this data, right? But it should not be repeated within that, like it should not be shuffled. That is why this random state we have mentioned. Okay, it should be like within the order only, and then we can give that data. So like that, that's random state is mentioned over here. It is not that much important, but we have to mention it. Okay, Now what we have to do is we have splitted the data. We are knowing now what is X is there, what is independent and what is dependent variable is there. All the things like libraries and dividing the data in order and all the things we have done. Now here comes the superhero of this model. Okay, which model we have choose, that we have to mention to over here. So now our time is that we have to tell it model selection. Okay, in simple words. So as we were learning about logistic regression, so we are telling that this is logistic regression and fit that data within your conditions. Okay, it requires means like calculation requires, right, according to sigmoid function it is going to adjust all the things and then it is going to do the classifications and calculations and all the things whichever it is requiring. Okay, we have given the data, we have splitted the data, we have told that this much data take for your training, this much data take for testing. Okay, so like that we have given the things. Now it's machine's work that we have also told that I want results with this model, logistic regression I want results with, and then fit it all according to your needs and then give me the results. Okay, now next part what it does, now we have given the model is being built, we have selected, it is fitted all the things according to its needs, right, it is all been adjusted. Okay, now next, what if this model is correct or not, this question arises, right, we need testing. So that is only the phase now it is going to be make predictions. Okay, so like that we are getting. Now here comes these three terms, that is confusion matrix, accuracy score and classification report. Okay, so let's understand these things in simple words and then we'll come again over here and then we'll understand this. Okay, but see first how is this confusion matrix. Okay, in confusion matrix we have true positive, true negative, false positive, false negative, like that, like those things are there. Okay, accuracy score is there, how much it is, 1.0. okay, this is there. In classification report it will tell us precision value, recall value, F1 score, support, and these things are there. Okay, just keep in mind that these terms are there and I'll explain these things in simple words. Okay, so what is confusion matrix? And a simple definition is that confusion matrix is a performance evaluation tool for classification models. Okay, it is a table that compares the actual values with the predicted values to show how well a model is performing. Now as we are in the testing phase, so that is why this confusion matrix is there. Okay, just remember in the confusion matrix we have matrix. Okay, there we have actual and predicted values. Okay, based on that this confusion matrix it is going to classify. Okay, so here's what the matrix tells us. Okay, true positive, model said yes and it was yes. True negative means model said no and it was no, model was right. Okay, false positive, what happens, type 1 error, model said yes but reality was no. And false negative, type 2 error, this is model said no but reality was yes. If we want to take any real life example, then let's say you are building a spam detector. Okay, now as we are building a spam detector, so let's take that example only. A spam email marked as spam, it is true positive. Okay, a normal email marked as not spam, it is also true negative. A normal email wrongly marked as spam, false positive. A spam email missed as normal, false negative. Now you see every model mistake has the real world consequences. Now there are some of the matrices from the confusion matrix, right? We saw that things, right? When we get the matrix, how do we use it? We have accuracy in that. True positive plus true negative divided by total predictions. Okay, it means that how often are we right? Okay, let's understand it there only. Matrices from the confusion matrix, that is accuracy. Okay, this accuracy is there. Accuracy, it has been calculated by true positive plus true negative divided by total predictions. It means that how often are we right. Next is precision. Okay, that is true positive divided by whole true positive plus false positive. Okay, it's like when we say yes, how often are we correct. Next is recall. Okay, true positive divided by true positive plus false negative whole square. Okay, so this is recall. Okay, it's like of all actual yes cases, how many did we catch. And F1 score, it is like 2 multiplied by precision into recall divided by those things. Okay, the balance between precision and recall, it is known as F1 score. Only accuracy score can also tell us most of the things. Then why we are not just using accuracy? Okay, It's the trap of the accuracy. Now I'll explain this with an example. Okay, imagine 95 out of 100 people are healthy. You build a model that always predicts healthy. It's 95% accurate but useless. It never catches the sick people. That's where precision and recall comes in, especially in medical fraud or crime detection. Now let's understand what this classification report is. A classification report is like detailed feedback from your classifier. It's not just like good job model. It actually breaks down how good the model is at classifying each class. It's the part of supervised learning, especially for classification problems like spam detection, fraud detection, or disease diagnosis. So now these terminologies are clear, okay, what this confusion matrix is. So this is how confusion matrix is, okay, actual values and predicted values, okay, +1, +2 means like true positive, true negative, okay, these things are there, true positiveness, true false positiveness, like it will tell us that whether we are actually faking any of the scene or faking any of the illness, or it's really an illness, like that things it can show us. This confusion matrix can show us, okay. This is the example of how confusion matrix looks, okay, and rest of the terminologies of the confusion matrix we have learned, okay. So what is classification report, what is precision, what is recall, all those things are now clear, okay. So let's move further in our logistic regression. Now let's see if a model can perform accurate or not, okay. Let's test it live. If we get it 2 links and 3 shouting words, it says, yeah, that's spam. Let's run this. This is the final step of our model, okay. Now you can see we have got the output 1. 1 means it is spam, okay. Means what are the inputs we have given? 2 and 3. Means like number of links are there 2 and capitalized words are like 3, okay. So what it has classified? It has classified it as spam or not spam? Yes, it is a spam email, okay. So like that the classification is done. So logistic regression isn't actually about regression. It's a classification model, okay. Now here this is there, okay. There is one more file I have created of this only, this mini project only I have created, but there is some of the different things that is present, okay. I'll show you that quickly. Here same project is there, okay. Libraries, then data set, same data set I have took, then visualizations I have made, okay. Then we have given this logistic regression model, okay. Here it is GUI based. GUI means graphical user interface based, okay. Means like now it is going to show us what is spam, what is not spam, those things are there, okay. But when we will execute this, you will see I have to run it from above. So now I have executed it. You will see the output. This is the output of that, okay. So spam detector, it has been created whole GUI. This is graphical user interface, okay. Means it has been created visually appealing, okay. That only simple output like yes or no, like that we were getting, okay. So same we will pass here. Number of links there were 2 and capitalized words were 3, okay. Even though if we pass different values, then also we are going to get the results. So it was spam, right? Here also. And when we will come in this predict, it's a spam, okay. So next if we'll change the values, like there are no number of links and no capitalized words, then if we'll predict, then it's not spam. So like that it is being categorized. So this is the different terminology. Same project is there, but just I have added some of the interface to it, okay, graphical interface to it, okay. That is with the help of GUI. If you all want to learn those things also, you can comment in the comment section. I can make those things also, okay. Otherwise I'll explain this project, or just that GUI part I'll explain, okay. So now most of the things we have covered over here, okay. Like what is logistic regression, we have built a simple project, okay. Spam versus not spam. You have got idea of how we are creating, how the model is learning, what is behind the scenes logic going on, right? You know, when we started this video, classification might sounded like a textbook term, buried somewhere between confusion matrices and sigmoid function. But look at you now. You just journeyed through the binary logic, multi-class decisions, and even braved the wild land of multi-labels. From zeros and ones to choices and changes, you have leveled up. This isn't just code. It's intuition, insight, and a little bit of algorithmic magic. So the next time your playlist reads your mood or your phone unlocks with your face, smile a little because you know what the spell behind the sorcery. Don't stop here. There's a whole world of data stories waiting to be told. And if you're down to learn them with me, hit the subscribe, join the tribe, and let's decode the future together. One model at a time. See you in the next one, Data Warrior. Until then, keep asking questions and keep training your brain.